Hello, good afternoon. How's everybody doing? Give me some energy. Come on, it's after lunch. It's after lunch. It's after lunch. Well, thank you all. Thank you all for being here. This is optimizing performance, deployments, and security for Linux on Azure. So thank you all for being here. I guarantee you I'm going to give you some high energy. So buckle up. We're going to take this journey together for the next 45 minutes because I know after lunch, all that food in your stomach, you're going to need a little bit of my energy. Okay, sound good? How's Ignite going? It's been awesome so far. We're day 3 in, day 3 for me at least. I know it's a long week, so buckle up. We got lots of excitement. So before we get into it, just a little bit about myself. My name is Lachlan Evenson. As you can tell by my accent, I'm local from Boston, not the other side of the Pacific.
He's right.
Yeah. Joined Microsoft in 2017, had 8 wonderful years at Microsoft, doing what I love, which is working on Linux and open source. I'm going to tell you all about that. I'm a principal product manager on the Azure Cloud Ecosystem team, Azure Cloud Native Ecosystem team. And a few things, because I always like knowing who's speaking to me. About myself, I've written 2 books on Kubernetes, and I am on the board for the Cloud Native Compute Foundation, where I get to serve in making decisions for the future of open source, which is a great privilege. And then finally, I love travel, culture, and language. I currently speak 3 languages, and that's not counting Australian English as separate to English. So I speak English, Japanese, and Spanish. So if any of those are your own passions, feel free to come and talk to me.
Yeah.
Karl.
Absolutely. My name is Karl Abbott, and I'm from Bellevue, Washington. I joined Microsoft last year in July as a product manager. Prior to Microsoft, I was at Element, which is an open source secure communications company, for 2 years. And then prior to that, I was with Red Hat for 16 years. A couple of my interests and hobbies, I like to do photography. I've got a website up there if you're interested. I run a product management podcast called Productly Speaking, which you can check out as well. I like to travel, I like to hike, and of course I like to mess around with Linux and computers.
Excellent. Thank you, Karl. So before we get into the main event, which is going to be deeply technical, so buckle up. We need to set the stage here. And I'm a storyteller. I love sitting around a campfire to get everybody in the mood. So how do we get here? How do we get to performance optimization for Linux on Azure? So in the beginning, or a long, long time ago in a galaxy far, far away, Linux made its way into the world being shadow IT. And over time, Linux became the operating system of choice for servers running the world's applications. And today, Linux is the foundation of all AI applications that we use daily. Running Linux is no longer a choice, it's the default. And just as our customers are choosing open source, Microsoft is also participating in a rich ecosystem and our immense community around open source. I, for one, get the privilege of working in open source communities like the Linux community and the Cloud Native Computing Foundation every day, which houses projects like Kubernetes as well as many others. So I don't have too much time to go into everything on this slide, but as you can see, Microsoft contributes to a large variety of ecosystems across the open source ecosystem, including Linux, cloud native applications, data and AI, languages, and the web. And it's not just us. Our top 100 customers on Azure and in the cloud also run Linux, open source, and Kubernetes, including databases as well. So it's not just us using and utilizing open source. Hopefully it's everybody in this room. And if you're in this room for Linux, obviously you're using open source as well. Now, when I first saw this slide, I've only been at Microsoft 8 years. I didn't actually, and I wasn't aware of the history that we had in open source. So our open source journey as a company has been long, probably longer than many of you know, and at least myself, and maybe you, Karl. It dates back to 2004 with Wix as our first open source project at Microsoft that was opened up on SourceForge. I'm going to point out just a few dots on this timeline here that I think are really interesting. If you go to 2009 up the top there, Microsoft made its first contribution to the Linux code base in the kernel with 20,000 lines of contributions to the Linux kernel. I think that's amazing. Fast forward there to 2014, you can see the .NET Foundation, which is open source as well. 2018, we acquired GitHub, and now today we have more than 100,000 repos. That says 10,000, but I know it's 100,000 plus repos on GitHub now, growing daily. And there's one little pointer that I think is really cool in our history in the timeline of open source at Microsoft is MS-DOS is actually available on GitHub. A few years ago, we put up MS-DOS.
We did.
So we made sure to get that in the timeline.
You want to see how that works, you can. And that's
you absolutely really cool. Have the source code. So I think that's awesome and really speaks to the depth of our history in open source that not many people know. So seeing it spelled out there is great. So now we're going to talk about the rich ecosystem of services to run your Linux workloads on Azure. With over 200 services, we have an extensive partner ecosystem, and there's never been a better place to call your penguin home. So hopefully you know the mascot of Linux is Tux, and Tux is indeed a penguin. So we thought it'd be quite cute and fitting to put Tux diving into Azure there.
And it wouldn't be Microsoft Ignite if we didn't talk about AI, right?
No,
but
absolutely not.
that was our AI contribution in this deck. So
yeah, there
AI
we go.
Generated, that is our AI contribution. We have now done AI.
That was all built on Linux too, so you know. The mastery of our collective knowledge goes into generating that image.
Yep.
So open source has to run on an operating system, and for most of our developers today, that OS is Linux, which is why more than 66% of our customer cores on Azure today run on Linux. But it's not just our customers. Hundreds of Microsoft services run on Linux on Azure, including Xbox, Microsoft 365, Azure Kubernetes Service, and many, many more Azure services. We even have our own distribution of Linux, Azure Linux, which we use for Microsoft services and make available to customers as a container host for Azure Kubernetes Service. Azure Linux is optimized for Azure and offers enhanced performance, reliability, and security. And if you're interested in Azure Linux, there's some folks from the Azure Linux team right in the back there you can have a chat to afterwards. And lastly, of course, the latest AI workloads such as OpenAI and ChatGPT also run on Linux in Azure. So on Azure, you can take advantage of the broad ecosystem of open source technologies. That includes databases like PostgreSQL, say that quickly 5 times, and MySQL, cloud-native technologies, and large language models, allowing you to run your workloads using your choice of open source software. Now, I love more AI, so we're going to teach you now and go really deep into how to train your penguin.
Yeah.
So obviously, you may have seen this slide before, but we love Linux. It brings me great joy to be up here on stage talking about all the things that we do in Linux and making a great Linux experience for you on Azure. Okay, so let's take a look at the Azure Marketplace. It's the starting point if you have a specific distro that you're looking for. It houses thousands of offers from publishers across the industry, including base OS images and applications. You can even build a base image from the Marketplace, and we're going to show you how to do that in a demo very, very soon. Customize it using Azure Image Builder and store that image in your own private image registry or gallery. Azure allows you to deploy and run your applications on the Linux distribution of your own choice. Our strong partnerships with leading Linux distribution publishers like Red Hat, Canonical, SUSE, Oracle, CIQ, Debian, Alma Linux, and Flatcar, as well as the broad ecosystem of community, ensure that you have an optimal experience running Linux on Azure. We have endorsed distributions, and an endorsed distributions is 4 things to us. First, we have a contractual agreement with the provider of that distro. Second, we have an engineering collaboration for which we work on bugs, issues, enhancements, and escalations are all discussed. Thirdly, we have a strong and sustained market demand for that distribution of Linux. And finally, the publisher is maintaining update infrastructure on Azure to enhance the user experience. I'd like to take a quick moment just to share a little news. We've just had celebrating our 10-year partnership with Red Hat, so let me highlight some successes of that partnership. So the Microsoft partnership with Red Hat started in 2015, and we've delivered milestone after milestone, bringing enterprise-grade innovation to customers at every layer of the stack. A decade of innovation together. We started with Red Hat Enterprise Linux in the Azure Marketplace with integrated support in 2016. We launched Azure Red Hat OpenShift, giving customers a fully managed Kubernetes platform on trusted Red Hat and Microsoft technologies. From there, we continued expanding, including JBoss EAP for Azure Service, delivering Ansible as a managed app, and extending our reach into government workloads with Arrow GA, which is the Azure Red Hat OpenShift service in Azure Gov. And now in 2025, we celebrate 10 years of partnership, we've hit another major milestone with the public preview of OpenShift virtualization or OpenShift Virt on Arrow, unlocking even more value for customers to help run VMs and containers side by side on a single platform. So when you think about that, that's what 10 years of strategic long-term partnerships look like. Sustained innovation, deep engineering alignment, and shared commitment to helping customers like you all with confidence. And we're just getting started. I think I got another 10 years in me, do you think?
Oh, absolutely.
Okay. All right, excellent.
You'd be good for that.
Okay, so let's go ahead and dive into the demo part. We're actually going to show the first demo, which is deploying a customized image. So you may start with RHEL as your baseline, and let's go ahead and flip over to the demo.
Yeah, so we started with RHEL as our baseline. We then switched it over to image mode, and from there, we'll go ahead and start, and 𝗦𝗲𝗀𝗀𝗀𝗀, take it away.
Absolutely. So you can see here we have 𝗬𝗲𝗀𝗀𝗀𝗀, our Linux VM running in the Azure portal. We click capture, and then we can select image. From here, we can give it some details about the gallery we would like that image published and stored in, so that we have access to run that up on other VMs in the future. We've obviously already run up a VM and customized it to whatever we need. So the snapshot and capture allows us to store that in our image gallery and then spin up a fleet of VMs running on that image. So you can see we're going through here, adding a version, and right now we're doing a check, and we're going to create an image that will be stored in our private image gallery. And as I said, from there we can spin up a new VM or set of VMs in VMSS using that image. So what you see on screen here right now is that deployment in progress. So that's creating that image that's created successfully. As you see there on the top right. Now we can go and take a look at that image, 𝗬𝗲𝗀𝗀𝗀𝗀, 2.0.0. And from that image, now we are going to show you how to deploy it. So we see here, we're going to give it a name, 𝗬𝗲𝗀𝗀𝗀𝗀, clone of 𝗬𝗲𝗀𝗀𝗀.
Yeah.
So we're following that lineage of How to Train Your Penguin.
A very creative name.
Very creative here. And we'll actually go ahead and select that, and we'll fill in a few more details, including the keys we're going to use, and we're going to spin up that image from the private image gallery that we just saved. And following that, we're going to actually show and prove that we're not just in the portal here by SSHing into that machine and actually showing you the clone is up and running. So right now here, we're selecting the license here, and we're using a RHEL license that we already have stored. Don't worry, we'll show you what that means later. And we're going to go in and create the VM right now. So we can see that deployment is taking place right now, and then you'll see command prompt window pop up here, and then we'll go ahead and SSH into that machine once that VM is deployed. All right, cue the Jeopardy music. It's coming on up.
That's right.
We're still going here?
We
Here
are.
it is. Okay, you can see up on the right. Thank you very much. Here we go. All right, so that deployment's in progress. You can see it creating all the elements, and now we can click Go to Resource and connect to that machine. So we see we have clone of 𝗬𝗲𝗀𝗀𝗀𝗀 up on the screen here. We're popping over to our command prompt. We're going to SSH into that machine using the key pair that we stored specifically and the username that we configured it to, which I think was 𝗬𝗲𝗀𝗀𝗀𝗀,
Yep.
in the vein of that.
Keeping that whole theme going.
The theme of training your penguin. 𝗬𝗲𝗀𝗀𝗀𝗀𝗀, at the IP address, which is the public IP address of that machine. We're going to SSH in and prove that we actually have a running VM. So there we go, SSH. Come on, no one hosts. There we go.
There we go, and you can see that it is our custom RHEL image mode VM. And we could do that 100 times, and we'd get the same copy of that 100 times.
Excellent. Well, the great news is great Linux distributions require great hardware to run on, and we have great hardware available on the Azure platform. So I'm going to talk about Cobalt 100 ARM-based processors. So last October, we actually announced the GA, or the first generation of ARM-based VMs based on an in-house custom-built ARM64-based Cobalt 100 ARM processors. This general purpose and memory-optimized VMs are well-suited to run scale-out Linux workloads and other cloud-native workloads. These VMs have a 50% better price performance compared to our previous generations of ARM-based VMs. And as of January 2025, these VMs are available in 21 Azure regions and are used by major companies in various industries, including Databricks, Snowflake, Elastic, Amadeus, and a major partner in the travel industry. Okay, now we're going to take a look at the different pricing options we have available as you run Linux on Azure. So we offer very flexible licensing options for deploying Linux on your Linux workloads on Azure. You can choose from a range of free community-supported Linux distributions, including Debian, Alma Linux, Rocky Linux, and Fedora. If you require a paid Linux distribution, for example, Red Hat Enterprise Linux, SUSE Linux Enterprise Server, or Ubuntu Pro, you have the flexibility to choose pay-as-you-go or pay-G, paying for only the resources you use, or a bring your own subscription or BYOS model, allowing you to use existing subscriptions in Azure at no extra cost. Azure is the only cloud provider to offer Azure Hybrid Benefit, which is a unique licensing solution which enables bidirectional conversion between pay-G or pay-go and BYOS, which is BYO subscription, for your Red Hat and SUSE subscriptions, including post-deployment conversions. So if you've already deployed as pay-G, we can actually convert them after. We're going to show you how that works. We also enable upgrades from free Ubuntu Server to Canonical's premium Ubuntu Pro offering. And just like with Azure Hybrid Benefit, this can be done on running VMs. And here is the key point I want you to know. You don't have to reboot the machine. So you can attach these licenses. We'll show you how to do that for all those distributions. So Carl's going to queue up the demo here. Are we almost ready to go,
yeah,
Carl?
We're ready to go.
Flip to the demo and show you how we're going to, for this demo specifically, we're going to show you converting between pay-G and BYOS and show you that no reboot is required. Thank you, Carl. Queue us up.
And here we go.
Okay, so we're in the marketplace. We have RHEL here. We're going to create a VM from RHEL. So we'll go ahead and click Create. So this is the view of what you'll see when you go into the marketplace and select RHEL. We playing there?
We are. We are. Takes a moment.
Look at me. I'm talking too fast.
I know. Yeah.
You know, it's that lunch. It's that lunch. Too many.
He told you he'd bring the excitement.
Yeah.
Is everybody
too many
excited?
cups of coffee.
Stand up if you
There
need
we
to.
go.
Take a
Okay, so
stretch.
we're going to click Create. Okay, select the resource group. We're going to create a new VM here from RHEL, and we're going to give it a name, which is obviously required. We're going to say the availability that we need. We're going to select RHEL specifically because we did that in the marketplace. Give it a username that we're going to log in with. And you can see right down the bottom here, it's coming into frame, the licensing part. So specifically, we're not going to select, you see the licensing part, not that we have an existing licensing
and that way it gets brought up as pay-go.
Exactly. So this is the default mechanism. It gets brought up as pay-go. So what we're going to do is review and create, and then go deploy that VM. Once we actually bring this VM up, we're going to SSH into that VM, just to show you what
First,
it
we'll
looks
go
like.
change off the license to BYOS.
Okay. We're going to show first that we're going to come up as pay-G.
Maybe we do.
Excellent. All right. Okay. So now we're going to the resource. We're going to pop over to our terminal. Again, we're going to SSH in using the key pair that we've used at deployment time, give it the username at the IP address so that we can SSH into it. And what you're going to see actually is that the RHEL box that's come up is indeed not using license-based subscription. And the way we can verify that is when we actually go and call the updates service in RUI. So right now we're actually going to go check for an update. And you see there, this is not registered with an entitlement server. So you can use Subscription Manager to register. However, we still have access to RUI or the update infrastructure for Red Hat. And we can see that we've pulled and we're starting to install the update packages. So even though this is at pay-G operational model right now, we still have access to pull the latest updates. Now what we're going to do is actually, in that running VM, without shutting it down, go into the operating system under the licensing section, say I do have a license. I do want to attach to an existing Red Hat licensing that I already have procured. And what this is going to do is change the configuration of that VM and make sure that we're now utilizing that license, which will bring us into BYO subscription mode. Now that all happens without a reboot. And yeah, is there anything else that I missed, Carl?
No, that's pretty much it there. I mean, once you've done that, you are going to need to attach a subscription from Red Hat to that system because of the way that they do their subscription modeling. But then at that point, you can use what you've already paid for.
Excellent.
And yeah.
Thank you.
All right.
Excellent. Now I'm going to pass it over to Carl, who's going to take us through security, compliance, performance optimization.
Absolutely.
Thank you, Carl. I'll trade places with you.
Yeah, let's go ahead and get this one queued up as well. Yeah, so as Lachie said, it's time to talk about security and compliance, which we've done a lot of at this conference. Now, there is a lot of information on the next couple of slides. We're not going to hit everything due to timing. We'd be here all afternoon if we did. So please note that you will get a copy of the slides after the presentation. So don't be too worried and don't feel like you have to take a
Screenshot of everything?
every single single slide because you'll get high resolution presentation deck. All right, so security is top of mind for the Linux community, and we see this in headlines all the time. We see things like the XZutils backdoor that was found by Microsoft. There's just a surge in vulnerabilities, and this has got everybody talking about how do we do things. Security is also top of mind for Azure, powered by our Secure Future Initiative, or SFI. So aligned with the SFI principles of continuous compliance and auto remediation, we have introduced the Linux Security Baseline, which is a list of security recommendations for general purpose Linux machines that's accessible through Azure Policy and Azure Machine Configuration. And we do that through CIS benchmarks. So we've brought these CIS benchmarks into this tooling so that we can provide you actual CIS level guidance here. We have right at about 3,300 OS level security recommendations covering our endorsed Linux distribution partners, and it is built into Azure and ready to use. It's in preview mode right now, but please go play with it and give us feedback on that. So like we said, it's available for all the distros except for once they go end of life, so yet another reason to keep upgrading and not stay on end of life distributions. It is customizable. It does come with L1 and L2 server profiles. Right now it is auto only, but I understand that they are working on how to do auto remediation. It does come to you at no cost as part of being an Azure customer, part of the benefit that the Azure ecosystem brings to your Linux ecosystem. Hybrid scenarios are supported via Azure Arc, so you could actually use this to manage systems over on AWS, GCP, or on-premise. And it is powered by Azure OS Config's new compliance engine, which happens to be open source and has a Linux native client. So you're not talking about trying to like bolt some Microsoft Windows thing on top of this thing. This is pure open source Linux goodness. And our CIS product certification is complete, so they even say that we're good to do this. So awesome. Now, I wanted to talk about performance tuning and observability on Azure because these are very, very big areas when it comes to running Linux workloads. When you workload tune, you are always going to be making a choice between optimizing for latency, which is the time that it takes data to get somewhere, or optimizing for throughput, which is the number of transactions or requests processed by the system within a specified time frame. It is extremely hard to get both at the same time, and you will always have a little bit of a balance in one direction or the other, even if you get an improvement in both. What to measure? So when you're looking at Linux performance, it's not really all that different. Linux is just an operating system, so same stuff if you've done computers ever: CPU, memory, storage, network, same building blocks. Azure VM performance tuning. VM SKU consideration is actually really important on Azure, and we'll speak to that in just a moment. But then storage optimization, network performance, and also wanted to let you know about Azure Boost. So Azure VM SKU considerations, we could spend all afternoon talking about all the SKUs we have on Azure. There are a bunch of them, and they are all formulated for very different use cases. You can choose those SKUs based on things like CPU architecture and generation, CPU core ratio, premium storage support, max bandwidth, cache size, performance, disk throughput, IOPS limits, and a whole bunch of other different things. But the key to note here, and we're happy to talk to you about this as Microsoft, we're happy to let you know what would work best for your scenario, but there are so many. Pick the one that's going to be right for your workload, and you're going to be way ahead of the performance game right off the bat. Then for things like Azure VM storage optimizations, you can pick different disk SKUs. If in certain use cases, it makes sense to actually pick an ephemeral OS disk. Caching can increase your performance by reducing the latency of data access, and we have a thing called UltraDisk, which is good for data-intensive applications, so a whole host of things to consider in that space. When it comes to networking optimizations, we have accelerated networking capabilities. We also have InfiniBand in some of our samples that you can go get and use. And we have a thing called Network Watcher, which is able to monitor the latency between Azure regions and or on-premise, and that really helps to monitor the performance of those network connections. So Azure Boost is an offload card, and for those of you who may not be familiar with what an offload card is, you basically take these very intensive network and storage operations, and you put them on a card that actually has a little computer on it to run that networking and that storage. And now, instead of having your VM have to do networking and storage, your VM can just say, hey, offload card, take the network storage and do it. And what this does is it frees up the CPU cycles on the virtual machine so that you aren't spending as much in the virtual machine actually taking care of networking and storage, and yet you've got this very dedicated piece of hardware that knows how to do those things and do them well. So that's an exciting piece.
There was actually, if I could call out, there was a cool session by Mark Rusinovich yesterday with Azure Boost using Linux between our 2 new Fairwater data centers, one in Wisconsin, one in Atlanta, and using RDMA, which is technology used to access the memory of another system. They could actually get about 950 gigabits per second with 33 milliseconds of latency. So there was a really cool demo on how we use Azure Boost under the hood to drive really high speed, high bandwidth operations. So you get access to that as a customer as well, and using L1VH.
Yeah, that's really cool. And that kind of speaks to some of the things that you can get when you use some of these Azure technologies in our space. Now, digging into Linux, so we've talked a little bit about Azure, but now when you dig under the hoods and you're actually at that SSH terminal, what can you do to measure performance? Well, we've got things like MPstat, which provides statistics on CPU usage at both the individual CPU core and combined levels, which can help you identify bottlenecks, and that's an example of what it looks like. You can just pretty much run that on just about any Linux box, and if it's not available, the package manager has a package with it, so you can go get those easily. They're available on any Linux distribution. VMstat, that provides high-level info on memory, paging, block I/O, and CPU usage, time spent in user system modes, and goodness knows, having troubleshot a wide variety of Linux issues, this is an extremely helpful tool.
Yeah.
Uptime is really cool because it's fast and it shows you how long the system's been up, but the very coolest thing about it is the load average. It's going to give you load average over the last 1, 5, and 15 minutes. So if you've just jumped on a box, somebody says it's going slow, you're now going to get to see what the load has been for at least the last 15-minute period. Measuring memory utilization. So there is the free command, which is going to give you things like total memory, used memory, free, shared, buffer cache, and available. That's a good one just for getting a general overall look at what's going on in the memory. We also have the IOStat command, which is part of the sysstat package because Linux people don't always name things the way you think that they would name them. So we're great at naming. At least it does say what it does. I mean, it gives you statistics on I/O. And that's kind of what that output looks like. Measuring network performance, we can do things like ping, which is going to help measure the round trip time that it takes for an ICMP packet to go back and forth. Also very good for helping to identify packet loss. QPerf can measure network bandwidth and latency between a source and a destination, and iPerf does kind of similar as well, where you have a client-server model. And in our demo that we're going to show you in a little bit, we use what's the one called? It's like a NTTTT CP.
Yeah.
It's got lots of T's in there.
Yeah.
CP.
Too many T's.
Yeah, and that's one from Microsoft that works out pretty well too. PIDstat helps monitor the CPU usage of individual processes, allowing us to identify any that are coming in with excessive resource usage. PS is going to give a snapshot of the current processes running on the system, and I feel that that's like underselling it a little bit because there's about 100 different flags you can pass into PS to get all sorts of different information. You can even figure out like what CPU core the different processes are running on. So if you're doing CPU pinning and like figuring out I want to move all of my database workloads onto CPUs 8 through 12 or whatever, you can figure out where things are and then start doing all of that, and you can go really far down a rabbit hole pretty fast and end up with an incredibly optimized system at the end of it. And then we have Top, which if you've never run Top, stop what you're doing, open up your laptop, pop up WSL, and run Top, because Top gives you a dynamic and real-time view of the system's performance, displaying information about CPU usage, memory usage, and the running processes, and it's just constantly running all the time, giving you that information. Good way to get a quick view of what's going on the system.
Sadly, you just went over 10 years of my Linux admin career in like 3 slides. I don't know if I'm happy or sad about that, but it was like I had to discover all those things on my own. So just if you take anything away, those 3 slides will help you.
That'll get you very far, very far.
Thanks, Karl, for making me feel like insignificant for 10 years of my career, but that's okay. That's why we're here.
Now on to the new age of Linux, Inspector Gadget, where we encapsulate eBPF programs in OCI images for powerful and performant systems inspection in a secure way.
Yeah.
Wow. Let's unpack that. An eBPF program, Extended Berkeley Packet Filter, is basically a kernel-level program that you can write in user space and inject as the root user from user space into the running kernel. It goes through a thing called the verifier to make sure that your program isn't going to do something bad because you are injecting it into a running Linux system, usually in production. don't want it to blow things up, and there are a lot of checks to make sure that it happens. As a result, the language is fairly limited in what you can do as well, because you don't want to be just injecting random code into your kernel. But it allows you to get to low-level system metrics out of kernel space and to be able to use them in a user space manner so that you can observe a very deep level in that Linux system. And by encapsulating them in OCI images like this, that gives us a great distribution model for getting these gadgets where they matter. And because it's container and K8s aware and system aware, so you can use it for Kubernetes environments or for just your running system, and it's delivered through OCI, this makes it very usable across the cloud, across your on-prem environments, edge environments. It's pretty much ready to go and be used anywhere. And to show you what that looks like, here we've got a gadget that we're running through Inspector Gadget. It's one called trace exec. So anytime the exec Linux system call is called, it's going to print out what command called exec, what the PID was, what the, I think that's the parent PID there, or maybe the thread ID, and then what the arguments to that command were. So you can see that every single time. And the way that we do this is we run an IG run, and then you'll see there is our OCI string of this is on ghcr.io in the Inspector Gadget subtree. And then I'm using -- host because I wanted to run it against the Linux system and not against the container. And you'll see the whole first column is for container names. So very much developed for Kubernetes environments, but also usable for regular Linux environments too. Now we're going to show you a demo, and before you hit play on that demo and we switch over, we'll go ahead and switch over, but I'll tell you when to hit play. What we are doing is we have two systems, one in Australia East and one over in US East. And when you go across the regions with network traffic, you have to tune for that if you want it to be as good as it can be. Like out of the box, Linux from one region to the other, you're going to get reasonable performance, and that's what we're going to show you at first. Then we have an entire Microsoft Learn page, which I'm looking out across this room, and I see a handful of people that helped write this Microsoft Learn page, where we talk about performance optimizations that you can make by setting kernel parameters around the TCP stack a little bit differently and setting a couple of UDEV rules. And then you're going to see, we're going to put those in place, and you're going to see just how much of an improvement it makes. So let's roll.
Ready?
And there it is, NTT TCP. And we're setting it up as a receiver. Then we're going to set up the other side as a sender. And you're going to see here, this is our throughput. We haven't done any optimizations. This is just a standard default Red Hat Enterprise Linux VM setup. And we get about 501 megabits a second on throughput. That test didn't run as fast. That's been sped up for the purpose of not wasting the rest of our afternoon looking at this. But that's roughly what we got over that.
That's out of the box performance.
That's out of the box performance.
It's not bad.
And this is that Learn page. So the Learn page link, I believe, comes with the presentation. But if you go look for optimizing network throughput, Linux, Azure, Learn, you will definitely get there. We have a lot of good content in our Learn section as well. And so this is all the different changes. I went through and put this all in files on my virtual machine so that I could easily move back and forth between tuned and out of the box so that I could actually do the testing to make sure that it was actually working. And so here we are applying those changes on one of those systems. You'll see it's just a handful of, those are sysctl.d files that go into systemctl. And then these are the UDEV rules. And then we're going to reboot the box so that all of these things cleanly apply. When we come into here, let's see. Here we're going to show you things like setting the I/O scheduler, which is how I/O is written to disk. By setting the none, we're basically telling the Linux scheduler to bypass doing any scheduling with that I/O and just write it to the disk. By default, there are like 3 or 4 other schedulers that generally ship in Linux, and depending on which Linux you use, depends on which one's going to be your default, but the kernel has different algorithms on how it will actually send that to the underlying disk to be written. And in some cases, it can get better. But here we've set up a receiver. Now we're going to set up the sender. This is with the optimizations in place. You're going to see already the numbers are a little bit higher than that 500 that we had before. And that's just with making a couple of changes here. And now we've achieved 710 megabits per second going across from Australia over to the East Coast of the US, and that's using a pretty standard VM type. I didn't pay a lot of money to run that demo. So it's pretty cool stuff what you can get just from those tuning parameters. Now, we have a lot of Azure native tools for observing workloads, because we could stand up here and tell you Linux runs on Azure, Linux runs on Azure. Great. Everybody knows that. It's the default. We want to tell you what Azure brings to the ecosystem. We have Azure Monitor. We have Microsoft Defender for Cloud, Azure Policy and Machine Configuration, which now we're delivering CIS benchmarking for you through. Azure Managed Grafana. Wow, that's a cool thing to be able to say, right? Open source project, Azure Managed Grafana, Azure Managed Prometheus. So these are things that are available to you as an Azure customer to be able to observe these workloads. And one really cool thing about Azure Monitor is that it is a full stack virtual machine and workload monitoring solution. And yes, that does mean it can work with Linux. And something really cool that we've just come out with in Azure Monitor is OpenTelemetry perf counters. So OpenTelemetry is an open source standard for capturing telemetric data for the observability of systems. And we've adopted that in a Microsoft first-party product, which is awesome. Love to be able to get up here and say things like that.
Helped start that.
Yeah.
The open census brand, and it became OpenTelemetry. So
very cool.
Another open source contribution.
Very cool. And what this allows you to do is, we'll show you the next slide, but one of the cool things we mentioned in this is the cost efficiency. By being able to store this as metrics as opposed to storing it as logs, you can look at reducing your storage cost by up to 80%. But check this out. Before OpenTelemetry, Windows counter names on the left there, Linux counter names in the middle, and now the OpenTelemetry on the right. The OpenTelemetry is the same as both of the ones on the left. So you no longer have to have two sets of counter names to be able to do that. And you can also see that there's gaps in the Windows counter names that Linux had counters for. Well, now they both have that counter. And there were gaps on the Linux side too, where Linux didn't have a counter and Windows did. Those have been cleared up, and now there's counters. And they're in this much easier to read dot notation and no slashes and things. It's much cleaner. I like it a lot. It's really exciting to see that. And also really, really cool, you know, we have a lot of slides here, and I was talking to the Azure Monitor team, I'm like, I can't add another slide, but this is so cool. Investigate issues faster with the Azure Copilot Observability Agent. Okay, one little piece of AI here, but this is so cool because it will sit there and do metric analysis on all the data that you have in your Azure Monitor to try to like point out patterns. And we all know that patterning is something that AI is actually really good at. So being able to bring those patterns and kind of point us at where to start looking to troubleshoot is going to save the amount of time that we spend looking at logs and metrics and trying to figure out where is my problem. So really excited to see that in action.
That's not mentioned is you're using natural language as well. So you don't have to understand the counter names or the query language. You can just use your native language.
Yeah, it really reduces that barrier to entry to actually start doing that performance analysis, because that's one thing that's been so difficult in Linux is like, if you don't know the internals of the system, if you don't know how an operating system works, and then you try to go do performance tuning or analysis on it, you have a large hill to climb. So that is, we're super excited with that. But summing this whole talk up, yes, you can run any Linux workload in Azure. And it's going to run really, really well, even out of the box. But then Azure brings so much to your Linux workloads. It brings so much to that ecosystem in which you run that. So by choosing to go with Azure for your Linux workloads are really going to shine, and you're going to get a lot with that choice. And then, you know, penguins go to Azure, and that's our back home slide. It's very much kind of wrapping that up, that this is a really great place to run your Linux workloads. There's a lot there for you. Linux is definitely a first-class citizen. As we said before, it really powers a lot of everything. Now, related talks that you could have gone to at Ignite, but they've all happened in the past.
There's a few, but you may want to follow up on the recordings.
Yes, you can follow up on the recordings. Most of these were recorded. For those that weren't, the decks are going to be made available, and certainly we at Microsoft are very approachable. If you're interested in having a conversation, feel free to reach out to the speaker on LinkedIn. I'm sure they'd be ecstatic to hear from you to talk about the areas that they're very interested in. So those have already occurred at this point. Azure Accelerate, This is our program to help fuel your transformation, your digital transformation projects with our experts and investments. Gives you the ability to access trusted experts, unlock Microsoft investments like partner funding and Azure credits, and to succeed with comprehensive coverage. You can go to aka.ms/AzureAccelerate to be able to know more, or you can capture that QR code and that will take you there. We did check our QR codes because we know how QR code spam can be. So we checked them. Get started and build Azure skills on Microsoft Learn. So this is a cool QR code. It's going to take you right into the Learn area. We have a lot of information on Linux. We have a lot of information on specific distros even, and how to do things on Azure. It's really good stuff that we have. I'll leave that up there for just a second in case anybody wants to grab that QR code.
I think it's awesome. I often go there and actually go through the learning modules just to learn more about the migrations we have. It's a great place just to pick it up and learn. We have a great environment there for you to be able to, whether you're new to Linux or you're already a seasoned professional in Linux, like many of the folks in the room or myself, I still have a lot I can learn.
And if you've never gotten started with Azure, you can go create a free account and you get a certain number of hours to go play with, and you can go start spinning up some small Linux VMs and getting started that way. Yeah. We also mentioned WSL, Windows Subsystem for Linux. If you've got a Windows box, you can start Linux right from your Windows box. Just go to the Windows Store. Ubuntu is probably the easiest one to find.
Yeah, absolutely.
And then you can just install that and go run to the gates. You can run a lot of different Linuxes on it, but that's probably the quickest to go find if you've never done it before.
Yeah, VS Code will actually set it up even easier, WSL, and get you an Ubuntu machine up and running on your Windows machine so that you can play with this too.
That's cool. And then we've got 3 related resources that we want to share with you. The QR code on the left is Linux on Azure Resources, aka.ms/Linux on Azure Resources, and that is a really, really good site to just kind of see what all we have out there. We have the Linux and open source blog, which is the middle one here, aka.ms/Linux and open source blogs. And that's over on Tech Community. And we put pretty much anything that's related to Linux or open source that we're doing, would put a blog out there. It's actually fairly active. So if you're not already checking that site on a regular basis, that's a good one to do. And then we have our Linux on Azure Challenge all the way on the far side here, which is aka.ms/Linux on Azure Challenge. So those are some excellent resources that we wanted to share with you. And then finally, how did we do? Tell us your thoughts about our sessions and complete the event survey. Everybody get your phones out and scan this QR code, because your feedback to this event helps ensure that we can continue to have Linux on Ignite sessions. And I'd like to say that we probably haven't had enough Linux on Ignite sessions. So if you'd like to provide that feedback to the organizers and let them know that we need more Linux sessions at Ignite, we would love to hear that. But please do share that with us and do give us your feedback. We are very much willing to hear it and act on it and improve for next year. So thank you all for coming to our talk.
Thank you. We'll be available outside for any questions afterwards. But thank you very much for your time and enjoy the rest of Ignite.